Hi, I'm Principal Shi. Yay! Welcome back to your classroom. Today, I'll be teaching you about the principle of moments. This presentation will explore the principle of moments, a fundamental concept in physics that will explain how forces cause rotation and how to achieve balance. We will also discuss its application in various scenarios. Now, I'll tell you how to understand moments. A moment, also known as a torque, is the turning effect of a force around a pivot point. It's not just the force itself, but also where the force is applied that matters. The moment is calculated by multiplying the force by the perpendicular distance from the pivot to the line of action of the force. A pivot is the point where something attached to it turns. So, if this was turning, then this would be the pivot. The equation is moment equals force times perpendicular distance. Forces can cause objects to turn in two directions only, clockwise or anticlockwise. Clockwise moments turn an object in the same direction as clock hands, while anticlockwise moments turn it in the opposite direction. It is important to distinguish between the two directions when calculating the total turning effect. Just remember, clockwise is just a normal clock because there's nothing before it, but anti-clockwise is the opposite of clock. It is important to distinguish between the two directions when calculating the total turning effect. The principle of moments states that for an object to be in rotational equilibrium, the total clockwise moment about a pivot must equal the total anti-clockwise moment about the same pivot. Rotational equilibrium means that object is not rotating or is rotating at a constant rate. The equation is total clockwise moment equals total anti-clockwise moment. Applying the principle on levers. Levers are simple machines that use the principle of moments to multiply force. They consist of a rigid bar that pivots on a fulcrum. By applying a force on one end of a lever, a larger force can be exerted at the other end. Applying the principle on seesaws. A seesaw is a classic example of the principle of moments. The pivot point is in the center rather than the farther edge, and the weights of the people on either side create moments. When the moments are balanced, the seesaw is level or perfectly straight. Now, I'll tell you how to solve the problems that you'll get about this. First, you need to identify the pivot point, then determine the anti-clockwise and clockwise forces. Then, calculate the perpendicular distances. After that, calculate the clockwise and anti-clockwise moments. Finally, apply the principle of moments. Now, I'll give you some example questions to see how well you listened. Number 1. A force of 50 N is applied 0.4 meters from a pivot. Calculate the moment. The answer is 50 newtons times 0.4 meters equals 20 newton meters. Number 2. A seesaw is balanced. A child weighing 300 newtons is 2 meters from the pivot. How far from the pivot must a 400 newtons child sit to balance it? The clockwise moment would be 300 newtons times 2 meters, which would be 600 newton meters. The anti-clockwise moment would be 400 N times the distance. So 600 newton meters must equal 400 N times the distance. So the distance is 600 newton meters over 400 newtons, which would be 1.5 meters. When multiple forces act on an object, the total moment is the sum of all the individual moments. Remember to consider the direction, clockwise or anti-clockwise, of each moment. A beam is pivoted in the center. A 10 Newton force acts 2 meters to the left, and the fourth 5 Newtons force acts 4 meters to the right. Is the beam balanced? The answer is 5 newtons times 4 meters, which equals 220 newton meters. The anti-clockwise moment is 10 newtons times 2 meters, which is also 20 newton meters. So yes, the beam is balanced. The principle of moments is crucial in engineering, construction, and everyday life. It helps us design stable structures, use tools efficiently, and understand how objects rotate and balance. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.